Hi, this is Maggie. In this video we're going to solve a programming problem by applying the problem-solving steps from the textbook. The problem-solving steps are: define the problem, identify and clearly express solutions, evaluate and select among those solutions, implement a solution, and finally evaluate the result. So, beginning with defining the problem, it's really important that you solve the right problem. Otherwise, you might spend a lot of time building something that nobody asked for, which could be a waste of time, money, and the goodwill of the people who asked for the software. Whether you're in school or working for a client, you will probably be presented with some sort of problem definition. And chances are, if humans wrote that problem definition, it will be incomplete and full of assumptions. Your first job is to make that problem definition as complete as possible and root out those assumptions and state them explicitly. So suppose we're instructed to use Python Turtle Graphics to draw a star. Simple enough, right? Is it? If we look at the Python Turtle Graphics documentation page at the top, there's a picture of a star. Is that the exact star you would have drawn? It's not the star I would have drawn. Here's NASA's page on stars. I wouldn't have drawn anything like any of these images either. They're made up of hundreds of colorful dots. Beautiful, maybe scientifically accurate, but not what I think of when somebody asks me to draw a star. So how do you define the problem? You can start by thinking about how the solution will look. In the case of Turtle Graphics, that literally is an image, but as you learn more about programming in Python, defining the problem will include how the program interacts with the user and how it will respond to different inputs. So imagine we talk to our client and we start by showing them some pictures of stars that we've found, and they shake their head and tell us they want a 5-pointed star. And then we learn a little more in talking to them. They want the lines to be thick and black. They want the star to be empty, and they want it as big as possible. They're using it for a craft project with young children. By talking to our client about the problem, we learned a lot, and we can write a clear problem definition. Draw a 5-pointed star as large as possible in the Turtle Graphics window using thick black lines with no fill. There's still some wiggle room here. How many pixels is thick? And what is the depth of those points? If it were really important, we would clarify that as well. Step 2 is then to identify and clearly express solutions. There aren't a lot of different solutions to this problem if we're told to program a solution in Python using Turtle Graphics. However, if you were told to simply draw a star, you might identify drawing by hand with a ruler and thick pen, drawing using a graphics program such as Visio or Paint, or drawing by writing a program to draw using a programming language such as Python. You would clearly express these by describing what is needed, maybe how long you expect the solution to take, and perhaps other factors such as whether you would have one copy or potentially many when you're done, whether you'd have an electronic copy or only a paper copy. Since we were asked to draw them using Python Turtle Graphics, that greatly narrows the potential solutions. Identifying and expressing solutions really comes down more to whether we draw the star using forward and right-left commands, or whether we draw it using set pause, or a combination of both. However we draw it, we should end up with the same star picture. To express these solutions, we should draw them on graph paper and include as much information as possible. The third problem-solving step is to evaluate and select among the solutions we identified in the last step. To evaluate and select, we need to have some criteria. Again, we're going to end up with the same drawing, drawn using Python, no matter which set of commands we use to draw. So we should probably choose the set of commands that we think will result in code that is easy to read and modify. As you learn Python, you will learn more criteria for choosing among solutions. Guido van Rossum, the creator of Python, said that code is read more than it is written, which is true. So we will use readability as a criteria here. Will it be easier to read code that uses the set pause commands or forward and left commands? Because set pause moves the turtle to an exact location and it is one command rather than two, set pause commands are probably going to be easier to read and modify. If we set the position to a particular coordinate and it's wrong, we need only change the coordinate. If we use forward and left, we might have to change both the angle and the distance, which is trickier. The fourth step is implementation, which means programming. Because we put so much detail into our clearly expressed solutions, programming this is really a matter of transferring those coordinates to a Python program using setpause commands. The final step is evaluating the solution. Now this is easy if we're drawing a picture. Evaluation comes down to a single question. Did we draw the picture or not? If not, then we need to figure out where the program went wrong, called debugging, and fix it. If so, then we're done. We should probably also show it to the client and make sure it's what they want. When we start writing more complicated programs that interact with the user, evaluating the solution will mean testing it for many different inputs and sequences of inputs, so it will take longer and there will be many more opportunities for our program to fail. So those are the problem-solving steps as they apply to solving a programming problem using Python's turtle graphics. Try applying the problem-solving steps to some of the challenge-accepted problems at the end of the chapter in the text. Once you can successfully apply all 5 steps to solve a programming problem using turtle graphics, you're ready to move on.